Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, we are going to be going through the final question, finally, of the Mathematics Literacy Paper 1 of the Grade 12 Mathematics Literacy Paper 1 that was written in June 2021, right? And the final question, guys, on this paper is question 5. And question 5 covers data handling. Okay, so before we get started with the video tutorial, guys, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you get notified every time I upload a new video. Please also make sure that you give this video a huge thumbs up, because that really helps the channel grow and it helps the channel reach more learners that want to better their mathematics marks. Also, please make sure that you engage with me, guys, on the comment section, right? Just tell me how you found the video. Was it helpful? Did it help you? Did I simplify concepts? Would you like me to change a certain way that I'm approaching the question? Please, guys, make sure that you engage with me, because that is how I'm going to be able to also improve in how I explain these concepts to you guys. All right, so without any further ado, guys, let us get started with the video tutorial. So like I mentioned, guys, on today's video tutorial, we are going to be going through question 5 of this grade 12 mathematics literacy paper 1 that was written in June 2021, right? And like I mentioned, question 5 covers data handling, right? So we'll be basically answering questions that require us to look at a frequency table. We are going to be looking at questions that involve a stacked bar graph, right? So please make sure that you watch this whole video tutorial, because it'll really help you guys in just applying concepts when it comes to those topics. Okay, so let's get started, right? Let's get started. So question 5, right? 5.1, right? So question 5 says, in South Africa, learners' marks are graded using level descriptors from level 1, the lowest marks, to level 7, being the highest mark. The information below shows the November 2019 mathematics literacy results for learners in a particular district in South Africa. Okay, so basically what they're saying is that in South Africa, marks are graded, right, using level descriptors. So the level descriptors are from level 1, which is the lowest mark. So level 1 is this one here, and level 1 is the lowest mark, to level 7, and level 7 is the highest mark, right? They are telling us that this information that we see from this line graph, right? Because you guys do agree that this is a line graph. So the information that is shown from these two line graphs, right, shows the November 2019 mathematics literacy results for learners in a particular district in South Africa, right? So that is what the information is showing us. Okay, so these are the results for the mathematics literacy learners for November 2019. Okay, so let's just analyze this line graph, right, guys? Because we do agree, this is not a scatter plot, right? This is not a bar graph, okay? This is not a histogram. It's not a pie chart, right? So it is, in fact, a line graph, right? So let's just analyze what these two line graphs are telling us, right? So here we've got a key, right? And this key is telling us that where we've got the squares, right? This is a bit thick. Where we've got the squares, right, that is the marks for grade 10 learners, right? And where we've got the circles with those lines there, okay, let me just zoom in, okay? Where we've got the circles with those lines going like that, that shows the grade 11 learners, okay? So let's just have a look. On the x-axis, right? So the x-axis is this here, right? The values that are on your horizontal line. So your x-axis, we've got L1, L2, L3, L4, L5, L6, and L7, right? Okay, and we were told that L1 is the lowest marks, okay, and L7 is the highest marks, right? And then L2, L3, L4, L5, and L7 are the marks that are in between, okay? And then let's go to the y-axis, okay? And the y-axis is the vertical axis, right? Here we are given the values of the number of learners, okay? So by looking at this, we can see, for example, looking at the first one, okay, if we look at L1, right, and we look at the first line graph that we have, or this line graph that shows the results for the grade 11 learners, right? So it tells us that 1,231 grade 11 learners, right, received a level 1 in terms of their marks. So 1,231 learners received L1, which is the lowest marks in grade 11, right? Okay, let's just look at L2. L2 tells us 1,990 learners, right, received L2, a level descriptor level of L2 for their marks, right? Let's look at L3. 1,357 grade 11 learners, okay, received L3, okay, got a level of L3. Okay, let's look at L4. Okay, L4 tells us, okay, so we've got a value that's below and the value that's above, right? So between here, we can see that for the grade 11 learners, it is above, right? So it's that 935. It tells us that 935 learners, right? So because it's above, we look at the above value. 935 learners received or got a level of L4. Okay, let's go here. L5, we're still looking at the grade 11 marks. It tells us that 551 learners received a level of L5. And then let's go to L6 and L7. It tells that 223 learners and 62 learners received the levels of L6 and L7 respectively, right? So that is just how we are going to analyze these two line graphs, right? So same goes with the grade 10 learners, right? Okay, for L1, 1,749 learners, okay, received the level L1. For L2, 2,239 learners received the level of L2, and so on and so forth, right? So this is pretty simple, guys. Okay, I've already answered how we're going to basically analyze this line graph. Now let's have a look at the questions and see what the questions are asking from us. Okay, so using the graph above, use the graph above to answer the questions that follow. Okay, so 5.1.1 says define the term range. Okay, so define. When they say define, guys, they're asking you to basically give the meaning of what range means, right, when it comes to data handling. Okay, so what is range? What do you know about the range of values when it comes to data handling? Okay, so guys, the range is the difference between the highest, okay, or the maximum value and the lowest minimum value in a data set. Okay, so the range is the difference between the highest value or the maximum value and the lowest value or the minimum value in a data sense, right? So just to simplify what I've just written, right, you can just say range, right, is equal to the maximum value, right, minus the minimum value. Okay, so the biggest value in your data set minus the smallest value in your data set. That is what range means. Okay, guys. Okay, let us go to the next question. Identify the type of graph that is shown, right? So like I mentioned, guys, this is definitely not a bar graph. It is definitely not a scatter plot. It is definitely not a pie chart, right? It's pretty simple. We know that this is a line graph. So they've basically used two line graphs here, right, to compare values for the grade 10 learners as well as the grade 11 learners, okay? To compare the grades or the marks for the grade 10 learners for the November 2019 mathematics literacy results. Okay, so they're using two line graphs to compare these values, right? So the type of graph shown here is a line graph. Okay, another option that they've also given here, you can also say that it's a broken line graph. Okay, so it's a line graph, guys. Okay, question 5.3 states whether the learner numbers represent continuous or discrete data. Okay, let us first discuss what continuous data and discrete data is before we even answer this question. Okay, so I'm just gonna make a side note here. Okay, so we're going to look at continuous data, guys, right? Continuous data. Okay, and we're going to look at discrete data. Okay, so guys, what is continuous data and what is discrete data? So guys, continuous data, right, is data that can be represented as a fraction. Okay, so data that can be represented as a fraction can be also considered as continuous data, or data that can be represented as an irrational number, right? So when I say an irrational number, I'm talking about a number that's like a decimal, like 1.5, 2.5, or 3.67 or 0.7, right? So that is continuous data. But discrete data is data that is basically numerical values that are whole numbers, right? So discrete data is if you're counting the number of people that attend a particular school, that is discrete data, right? Okay, or if you're counting the number of cars that went into a garage to pour 93 unleaded petrol, right? That is discrete data. Because when it comes to people, because I'm going to give you an example by drawing, because I think it's always good to use diagrams to help explain, right? So discrete data, I'm going to use people because this is going to help you remember, is data that can be represented as whole numbers, right? Okay, and guys, what are whole numbers? We know that whole numbers is like 0, 1, 2, 3, right? Whole numbers are not fractions. Whole numbers are not decimals, right? So it's like 0, 1, 0, 1, 2, 3, right? Going on and on like that, right? So an example of this is when you count, for example, e.g., when you count the number of people that attend or the amount of learners that are in grade 12 in Germiston High, or the amount of learners that are in grade 12 in Boksburg High, or the number of learners that are in grade 12 in Benoni High, right? You are counting the amount of learners, and you cannot get 1.5 learners, right? You only get like a full learner, 1 learner, 2 learners, 10 learners attend go to Boksburg High, or there are 10 learners that are in grade 12 in Boksburg High, or there are 20 learners that are in grade 12 in Benoni High, right? So it has to be whole numbers, because you cannot get half a person, right? Okay, you cannot get half a person. So it has to be whole numbers, okay? Or the amount of cars that poured 93 unleaded petrol, right? Okay, you cannot get 10.5 cars that went into Cecil Garage to pour 93 unleaded petrol. You get like 20 cars that went and poured 93 unleaded petrol. You get 10 cars, right? So it is whole numbers, okay? Yeah, this might seem unnecessary, but trust and believe it will be necessary, right? So discrete data is whole numbers. But when it comes to continuous data, this is data that can be represented like as a measurement, right? So for example, when you just measure out the weight of a person, when you jump onto the scale, okay, let me just write this. So this is data that can be represented as a fraction or irrational numbers. Okay, so what do I mean by this? Okay, for example, e.g., when I talk about fractions, it can be 1 over 2, 3 over 2, 4 over 7, right? Okay, or guys, right? Or another example, it's 0.73 or 0.32, 7.231. You get the point, right? So it's any data that can be represented in this form, right? And like I mentioned, you cannot get a 10.5 people. You get 10 people, or you get 100 people, you get one person, or, things like that. So for continuous data, it's values that can be represented like this, right? So what are values that can be represented as a decimal? For example, if you jump onto the scale and you measure yourself and you see that, oh, okay, I actually weigh 69.9 kg, right? That is an example of continuous data. Okay, so like weight, okay, right? Your age, okay, your age is an example of continuous data, because you can say that I am, for example, you get moms that like saying that my kid is 12 months old, or 1 year 3 months, right? So that is also an example of continuous data. Okay, so that is the difference between continuous data and discrete data. Continuous data are values that can be represented as a fraction or an irrational number, right? Fraction or irrational number. It can be represented as a decimal. But when it comes to discrete data, discrete data is data that is represented as for example, whole numbers. So counting. Okay. So I'm just going to give the full definitions of continuous data and discrete data, and I'm going to put them on the screen. Please make sure that you write down these full definitions, because these are just examples, and also please make sure that you remember them. Okay, so let's go back to the question. So now that I've explained continuous as well as discrete data, looking at this question, what type of data are we given here? Okay, so it says that the results of grade 10 and 11 learners according to level descriptors. Okay, so is this an example of continuous data, or is this an example of discrete data? Because they are showing us the number of learners, right? Counting the amount of people that received a particular level of results is an example of discrete data. Okay, because people, you cannot represent people as a whole number. You can't say I had 100,5 people. It's either you've got 100 people or you've got 101 people, right? So you can't get 100.5 or 100.5 people, right? So this is an example of discrete data. Okay, so 5.1.3, right? This is an example of discrete data. Okay, and I've explained what discrete data is. Okay, let's go on to the next question. 5.1.4, determine the total number of grade 10 learners who sat for the examination, right? So we need to determine how many grade 10 learners sat for the examination. But to determine the total number of grade 10 learners who sat for the examination, how many grade 10 learners sat for the examination? How many of them? Okay, so what do? We go to our line graphs, right? We look at the key. The key is telling us the grade 10 learners is shown by the squares, right? So the colored in squares is the key for the grade 10 learners. So we're going to go to the grade 10 learners. So how many of them sat for the examination? So you're going to take this 1,600 749 plus this 2,239 plus this 1,618. Okay, like so with this line graph, it's going below, so you're gonna plus the number that's below, so it's going down like that. So it's not going to be this number at the top, it's going to be the number at the bottom, plus 903, right, plus 429 plus 150 plus, it's not a 62 plus, it's 16 because it's going down like that. So you're going to take the value at the bottom. Okay, so I'm going to write all those values down. Okay, so it's going to be 1,000. It's going to be 1,749 plus 2,239 plus 1,618 plus the value at the bottom because it's going down like that. So you're going to look at the value that's at the bottom. So 903 plus 429 plus 150 and plus 16. Okay, and then literally guys, you're gonna put all these values in your calculator. Okay, I think I can move that now. Okay, so the total number of grade 10 learners who sat for the examinations are 7,104 learners. Okay, next question. Write down the level descriptors which show that the performance of the grade 11 learners is below the performance of the grade 10 learners, right? So when you look at these level descriptors, right, okay, where do we see, right, that the performance of the grade 11 learners? So looking at our line graph, right, let me actually just take it up like that so I don't have to go. Okay, so looking at this line graph, guys, right, so looking at these two line graphs, where do we see that the performance of the grade 11 learners is below the performance of the grade 10 learners, right? Okay, so we just look at the two graphs, and then where is the performance of the grade 11 learners lower? Okay, so the performance of the grade 11 learners is below the performance of the grade 10 learners where? Okay, so the performance of the grade 11 learners is below the performance of the grade 10 learners at L2. Okay, at L2. Okay, and the last question, determine the median level descriptor for the grade 11 learners. Okay, question 5.1.6, determine the median level descriptor of for the grade 11 learners, right? So what is the median level descriptor here? So how do we get the median, right? So I'm going to show you how we get the median. Is that okay? Some would even think that okay, I can go to determine the median level descriptor for the grade 11 learners, right? Some might want to actually look at all the values for the grade 11 learners. So the values are for all the grade 11 learners, right? For these level descriptors, right? For L1, there's 1,231. So we need to know that, okay, when you want to arrange your data, you need to first arrange it in ascending order, right? So this is another option. Okay, or we're going to first arrange our data in ascending order. Ascending order, by ascending order, I mean from smallest to largest, right? So for our grade 11 learners, we can't start with 1,231 because that's a big value. 1,990. We can't start there. So we need to start with the smallest value, the smallest number of learners, right? For the grade 11s, right? So the smallest, okay, it's 16 learners, okay? Let's see for grade 11. No, actually, it's 62 learners because for grade 11, we look at the, I'm going to highlight it. Okay. For grade 11, we look at this one here that's at the top. Okay, so I'm going to make it in nice pink so that you see what I'm talking about. Okay, so for the grade 11 learners, we'll look at the pink line. Oh, I hope you can see that pink line, right? Okay, we're going to be looking at that pink line. So let's look at these values. So it can't be 16 because 16 is the grade 10, it's below. So it's going to be 62. So the smallest value is, you're going to say it's 62. Okay, then you go, okay, let's see. It increases 223. Okay, we go 551. Okay. Okay, the grade 11 one is above, so it's 935. Okay, 1357. Okay, and then actually it's not 1357. Which one comes first between 1231 and 1357? It's this one. So you want to put 1231. Okay, because we're not going in that order, but we're going in which number comes first, because you're going in ascending order, right? Ascending is from smallest to biggest. So which number is smallest between this one and this one? Or which one is the smaller value between this one and this one? So the smaller value is the 1200 and so it's 1231. Okay, so that's that one, and then 1357, and lastly 1990. So that is the biggest value on this data set, right? So how do we get the median? Okay, how do we get the median here? Okay, we can simply get the median by counting like what I did: 1, 2, 3, 1, 2, 3, right? So we need to have 3 values on either side. So that is the median, or the median for this data set. Okay, so when you look at 935, so you're going to go to 935 on your data set, right? And 935 is for which level? L4. Okay, therefore it's L4, right? So that is another way that you can also do that. Okay, so the median level descriptor, if you choose to use this second method, is L4. Okay, and I've actually noticed that this video is actually pretty long, guys, right? So I'm gonna stop it here. And the next video tutorial, I'm literally gonna upload it the next day. We're gonna be basically solving this last question. Okay, so in the next video tutorial, guys, literally the next day, I'm going to be uploading question 5.2, guys. And with question 5.2, guys, I'm going to be showing you guys how you basically analyze a frequency table. Okay, so I'm going to be showing you guys how you can analyze this frequency table. And we're also going to be going through a question that involves a stacked bar graph, right? So please make sure that you are subscribed to the channel, right? Please also make sure that you hit the notification bell so that you get notified when I upload this video tutorial. But like I said, guys, it's literally gonna come up the next day. Okay, I hope you enjoyed this video tutorial, guys. I hope I actually went into detail in explaining things like continuous data, discrete data. I hope you understand what is the meaning of range. I hope you also understand how you're supposed to analyze these two line graphs that are used to compare the number of learners that receive these different level descriptors. Okay, guys, so that is it for today's video tutorial, and I'll see you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.